1.5, parametric relations and inverses. So a parameter is a natural way to define functions or relations and that is to define both elements of the ordered pair xy in terms of another variable t. Okay, so these functions will have x and t, y and t in them. Okay, so that's what that means. All right, so then we've got inverse relations and inverse functions. The ordered pair AB is in a relation if and only if the ordered pair BA is in the inverse function. So I'm going to draw a picture here to show what I mean by that. I'm just going to draw two graphs here. All right, I'm put a couple little marks here on each one. All right, so I'm going to have, undo. Gonna have this point, and this point, and this one. And then over here, I'm gonna have these ones. So I've got the point 1, 1 and the point 1, negative 1. And then over here, I've got 1, 1. And I've got negative 1, 1. So the ordered pair AB is in a relation if and only if the ordered pair BA is in the inverse. So that would be this one and this one. Okay, and technically you could say the same thing for the 1 and 1, but the ones that I've drawn the little arrows to are the ones that'll show it to you, since they've got the positive and negative in it, specifically. All right, so hopefully you remember us talking about the vertical line test. Okay, that's the line that goes up and down and goes through, and it'll tell us if something is a function or not. But the next thing we have is a horizontal line test. Okay, so this says the inverse of a relation is a function if and only if each horizontal line intersects the graph of the original relation in at most 1 point. Okay, so this is a line that's going to be drawn this direction, okay, just so that it's not confusing. So I'm going to draw 4 little graphs here. They don't need to be anything spectacular. They got skinnier as I went across. Oops. Oh well. Alright, so this first one, something like this. Let's see, this one, I've got something like that. And something like that. Okay, so 1, 2, 3, and 4. All right, so I'm going to use this to answer a couple questions. Which graphs are relations of functions? Okay, so with that, we're going to check the vertical line test. Okay, so remember that is trying to find a color that I want to use. Yeah, green's fine. All right, so it needs to pass the vertical line test. So remember, that's the one that's going up and down. So it can't intersect at any more than 1 point as you go across from left to right. So as I go across in 1, okay, take your pencil and slide across. Okay, I know you can't see it, but 1 does not intersect anywhere twice. 2 intersects at 2 places pretty much the whole way across. 3 is basically, well, it's not a circle. It's a funny looking thing, but it crosses twice. And then in 4, it may look like it a little bit just because of how I drew it, but it's not supposed to be overlapping at all. Okay, so with that, 4 is also 1. Okay, because it passes the vertical line test. And then part B, relations. So which of the graphs are relations that have inverses? That are functions. All right, so with this one, we're checking the horizontal line test. So this one's going this way. Okay, so I'm going to take my pencil and turn it, and as I go down, okay, through 1, there's nowhere that it intersects at more than 1 point, so it is, at 2, again, as I go down, there's nowhere that it intersects at more than 1 point. 3, okay, again, it's one of those weird shapes, and so it intersects at 2 places several times. And 4 does the same thing, okay? So as you go down, it intersects at multiple places. So the only 2 that are relations that have inverse functions, or that have inverses that are functions, are 1 and 2. Okay, a couple more little note things here, and then it'll be done. If F is a one-to-one function with domain D and range R, then the inverse function of F, denoted f to the negative 1, is the function with domain R and range D, defined by f to the negative 1 of B is equal to A, if and only if, okay, remember that's what IFF is, f of A is equal to B. Alright, so if I told you to find an inverse, think about if you remember how to do that. I think we briefly talked about it in Algebra 2. It's really simple. So how do we find an inverse? It's 2 steps. Swap x and y, and then solve for y. All right, and then we've got the inverse reflection principle. And this states that the points AB and BA in a coordinate plane are symmetric with respect to the line y is equal to x. The points AB and BA are reflections of each other across the line y is equal to x. The inverse composition rule a function f is one-to-one with inverse functions g if and only if f of g of x is equal to x for every x in the domain of g, and g of f of x is equal to x for every x in the domain of f. Alright, so sorry for that little glitch there that's going to be in the middle of the video. It shut off while recording. So sorry about that. It's a little weird how it did that probably. Anyways, we'll go over all of this in terms of actually doing problems and stuff with it. Obviously in class. But I wanted to make sure that I went through all the notes with you that you need to be ready here and to get a start to the understanding of exactly what's going on in this section. So, but that's it for the notes for this.